Hello everyone, welcome to this webinar by Evident on simplifying the screen of phased array ultrasonic weld inspection data using the new merge B-scan functionality. Thanks for registering to this webinar. As promised, you're going to hear about the benefits of the merge B-scan for weld analysis. You're going to see a little bit of how it works and how it compares with existing views. And we're going to spend quite a bit of time on some recommended practices and tips using actual weld examples and weld inspection data. So as an additional reference, you can also see the Evident blog still under the Olympus-IMS website that's listed there. This blog explains quite well about how the merge B-scan is made and resumes the benefits a little bit. So I am Tommy Bourgeois, product director with portable phase array units at Evident. And without further ado, let's dive into the subject. So we recently introduced that new functionality called the merge B-scan. This is actually a very, very simple functionality, but unbelievably, it seems that it was not in use earlier. We decided to file a patent for it. The main benefit of this functionality is that it simplifies and accelerates the screening portion, the screening of phase array weld inspection. It does very little to characterize the indications. It's mainly for the screening phase, meaning locating the indications in the first place. In some cases, as I will demonstrate, it can help facilitating the sizing, but this is not applicable to each and every weld. So the merge B-scan is available with the OmniScan X3 series phase array equipment using the MXU 5.13 software revision and up. And same applies with the PC analysis software OmniPC. So you need either MXU or OmniPC 5.13 and higher to use the merge B-scan function. I will actually use today a lot of OmniPC with existing data files for my demonstrations. On the benefits of the merge B-scan, I will go briefly in that section, primarily because we have been, as Evident, we have promoted a lot about the benefits as of late. So these benefits have not changed. So the main one is really that you can spot suspect indications at a glance on one screen. So if I compare a normal B-scan with the merge B-scan, it's a more crowded view, but the indications tend to be exposed a little bit easier. In most cases, it's possible to display pretty much everything you need to see in a single screen. I said in most cases. There are exceptions to that, and we're going to dive in the subject. So another benefit is you can easily identify weld geometry and index drift, whether it's the weld that is actually changing from the ideal straight pattern, or whether it's the so-called standard wandering. The merge B-scan allows to see that quite clear. Actually, you can see the geometry lines as can be seen on this picture, and the fact that they are repeated at different sound path, the geometry echoes, just make the understanding for the human eye that there's a drift occurring a lot easier with the merge B-scan. When the image is not satisfactory, and I will show you when it's the case, it's possible to actually adjust it using the first beam, last beam controls. They can become quite handy depending on the weld configuration. I will explain later. I will demonstrate that later. That will be hopefully a better explanation than this short slide. Another benefit, of course, because it's on board OmniScan X3, it's available live as you scan. So if you have a weld configuration where the merge B scan is really helpful, you can display it on the instrument as you scan. This is especially handy for manual scanning. If you're performing manual phase array weld inspection, we actually added a new layout. We call it BSA, B first, because the B scan takes the most place on the screen, like on that picture. The reason is the taller image with the merge B scan just makes interpretation a little bit easier than if it was a little bit squeezed vertically. So we decided to go ahead and create that new layout, which is especially handy for acquisition. The merge B scan is a toggle on-off feature. You can quickly compare merged and unmerged views. There's a toggle in MHU. If you use the OmniScan directly, you can hold, we call it the long press. You can basically touch the screen, long press, and toggle between activate merge B scan or use active beam. If you're using OmniPC, like I will be using today, you have to use the mouse right click, just like any Windows contextual menu, and you have a quick access to activate or deactivate the merge B scan. Actually, I'm going to, on that subject, I used that functionality a lot personally. I find it very helpful to toggle between the current beam and the merge view, simply because of the comfort that it provides. I like to make sure that I'm not missing anything, and then I display the merge B and I can scroll through indications. But again, I will demonstrate that slightly later. We also have layouts for multi-group phase array analysis. This is no exception. This is a dual group weld inspection where right now I'm showing C scans, and using this PowerPoint animation, I'm basically changing the image for 2 B scans showing the merge data. So the merge B scan shows indications a little bit clearer as opposed to what I had with the C scan only. Now, some of them were not impossible to see, but the merge B just makes them stand out a little bit more. Layouts are also familiar. So basically the benefit here is that without changing, I wouldn't say anything, but without changing much, you can still use the layouts that you like and activate the feature, and that gets you upgraded merge B scan view without having to change your habits or layouts that you're familiar with. In some cases, as promised regarding the flaw sizing, I touched briefly on that at the introduction slide. In some cases, it's possible to have an estimation of where the deepest part of a flaw is located. Now, some cases, my interpretation, my current assessment or interpretation of it is, it basically applies for the first leg, especially useful for ID flaws. Now, the deeper, let's say the farther away in sound path an indication is, the less useful the merge B scan tends to be. So the merge B scan tends to be more useful early in the sound path than it is very far away from the ultrasound entering the part. So when sizing indications that are in that condition, we have, in this case, it's actually this is a seared curved part, and we're sizing a crack that is present at the has, and it's not too deep in the part either, in the sense that compared to the entire sector, we still have the signals coming in early in the merge B, and we can actually see the tip diffraction very clearly, and that helps to position in a little bit more rapidly the data cursor in order to characterize this flaw. So the merge B scan does not characterize anything for you, but it can help to spot the deepest indications without having to search for different beams, and basically you can detect it, you can find it with a little bit less time. Merge B-scan, since it's a function of it's a feature available in OmniPC, and OmniPC already reads most OmniScan X2 or S6 data. Well, you can also use the new merge B-scan with previous OmniScan files, OmniScan X2 or S6 data. So a frequent question with the merge B-scan, actually, how does it work is a frequent question. So as I explained, it's a very simple functionality. With a sector scan, a regular sector scan, we can pretty much resume the explanation to combining the amplitudes at each ultrasound axis and displaying the maximum value. So we're basically merging along the sound path, very close to that. Now that gets a little bit different when it's linear scans or compound scans. The more accurate answer is that we actually merge perpendicular to the propagation axis. But for primary explanation, assuming it's along the sound path is not a bad approximation at all. So actually for most sector scans, it is a very accurate approximation. So a simple way to put it, and that's what the blog explains also, is if you were looking at the merge B scan, at the B scan or a sector scan, like a handheld finned fan there, and if you're folding that fan, that's basically your merge B scan. I'm sorry, I struggled with the explanation a little bit, but Paul did much better than me there. You can watch his video on YouTube. You can find it on LinkedIn. This is Paul Holloway explaining about the merge B scan as he's experimenting it. He's using it on a couple of weld examples. So a common, I want to say, misconception or reaction to the merge B scan is, oh, it's a side view. So I think everyone that I either explained this functionality to or introduced it to or heard about reacted like that. It's probably the most common reaction. Often I would hear, oh, it's the side view we used to have in TomoView. It's actually not that. Where it gets confusing is if you think of 0° corrosion data or composite 0° scans, well, this is where it gets a little bit more complex, because technically your 0° side view is very close to a B scan, or can be called a B scan, and that's an accurate statement. But where it's not the case is for angle beam weld inspection, which is primarily performed with angle beam, whether shear or longitudinal for austenitic materials. So our weld site software, the evident weld site software, actually displays side views and top views. This is a screenshot from weld site with the 3D modeling there. And top views and side views, or even end views, they are what I refer to as part views. Now, if you're inspecting a part, the top, the side, and the end will always be the same regardless of the method that you're using to scan. Now, we're using phase array here. I could use TFM, I could use TOF ultrasound, I could use eddy current, magnetic particle, I could use radiography, and probably a lot of other methods, but the top would still be the top, side would still be the side. So it's a part dependent view. In opposition, we have what I refer to as signal views. So signal views have at least one of their axes that represents a component of now it's mostly an electrical signal nowadays, because everything goes through processed electronics. In the case of ultrasound, an A scan plots the detected amplitude versus the time of flight or ultrasonic travel. So we have two signal components in an A-scan. So no question, the A-scan is a signal view. It's actually often referred as the signal. And a B-scan is, in my opinion, using this logic, is also a signal view because it represents the ultrasonic travel versus the scan axis. Now, the scan axis can be deemed a common axis with the part, yes, but the ultrasound axis represents a angled cross section with reflection of the back wall, so it's kind of a complex path that the sound takes in the part, so it's not directly applicable to the part immediately. So I'll stick with the signal view. Similarly, a C-scan is also a signal view because it represents a bunch of angles or virtual probe apertures, depending on the probe you're using. It represents a lot of angle against the scan axis. So all of these signal views are probe dependent. If I were not using a phased array probe here, I may not have a C-scan to inspect that part. I may have another type of view. If I were using radiography, I would have a film. I would not have a signal view like this. So this is the difference between a signal view and a part view. Now, how does that translate to actual representations? The way I like to explain this is each of these views that I just explained, the top view, projected top, projected side, C-scans and B-scans, they're all different points of view looking at reconstructed or corrected ultrasonic data. The projected top view looks down, basically as if you were looking from the top, at the top of the part or the weld, looking down in the echoes inside the part. Similarly, the projected side view is doing the same from the side. Now, looking at C-scans and B-scan, in particular the merge B-scan, when we're considering an angle beam C-scan, we're actually looking as if our eye was the probe. So this is why the echoes from geometry echoes are so large on the C-scan, just because of the beam spread associated with each echo reflection. But on the sound path axis and looking perpendicular to the propagation axis, this is our new merge B-scan. Now, if you're looking at only one B-scan, you're looking at only at the slice. If you're looking at the merge B-scan, you're looking at the same perspective, but combining all of these, basically all of the data points that are perpendicular to the propagation axis in respect to one another. So I tried to illustrate one weld using different representation. This is using WeldSight, of course, and OmniPC. The C-scan will be the same from in WeldSight or OmniPC, and I'm basically displaying angles against scan axis, as I explained before. And all, by the way, on all these 4 examples, I'm using very similar gate settings or projection cursor settings as much as can be, because of course they are different points of view. I cannot truly isolate exactly the same signals in these 4 situations. So I tried my best to select the very common region. I was not always able to because of just the nature of the echoes. As example, on my top right view, this is a projected volumetric side view in the weld side. If I wanted to be accurate and use the same volume in the weld, I had to include some mode conversion signal in the middle. Of course, I can clean this weld further if I exclude these from the projection cursors. Actually, you probably want to check weld side from our website, from Evidence website, and learn more about it, because there are some very handy volumetric merge top and side projection cursors. But all right, so next image, projected volumetric top view, is a very handy, shows very narrow indications. It's like looking at the top. And finally, we have the new merge B-scan that, by the way, is available in OmniPC, but also in the website. The merge B-scan shows it's uncorrected, but at least shows very sharp signals and a little bit more clearly separated from one another. So what it lacks in correctedness, let's say, it will gain in clarity of signals. So this is my practical portion of the meeting. Let me show you some examples using OmniPC. All right, so I have prepared a few examples using OmniPC. Actually, my latest OmniPC. And this is a manual weld. Of course, by manual weld, what I mean is a manual inspection using phased array of a weld. This is a relatively short weld, no more than 300 millimeters, scanned with several passes on each side. This particular pass happens to detect more than one indication, so I used it for example. So I'm going to show you my preferred methodology to use the merge B-scan. Of course, it's only the let's say the usage of one person. I'd be quite curious to discover how you are planning to use it, how you are actually using it. The way I'm showing it to you comes after analyzing only so many files, probably not as many as you guys will do in the field in a year anyway. So I'm sure this method can be improved a lot. So what I like to do to start is use the ABCS layout. Now you're going to see me or hear me repeating this for every weld that I'm going to show you up to the end of that webinar. So I start with ABCS. Then what I do is I like to display the gates in sound path. And why sound path and not true depth? Because I can actually see them on the merge B-scan. So, and the reason why I actually take the time to do this is I'm going to isolate the interesting portion or the portion of interest in my sector scan. And then I'm going to enable the merge B scan. So right click, activate merge B. And now I know from the gates position, I know what portion I can actually let go because it's just farther in time. And you may remember earlier in the meeting, I said the closer it is in time, the closer the signals are in time, the more useful the merge B scan is, and the farther away they are in the material and skipping over, the less useful the merge B scan becomes anyway. So most of the interesting signals will still be early in the material. So merge B scan at this point, I have pretty much optimized the view for the merge B and also the C because I used the gates. So I can see some indications from the C scan that are worthy to look at. 1, 2, 3, maybe something here, but the merge B scan shows a different perspective, and I can see the strong geometry, root geometries here, but I also see indications that stand out of the ordinary. So of course I want to review them. Again, this is a help for the screening. I'm not going to do any interpretation like putting cursors and sizing or characterizing any of these flaws. The goal of this webinar is only to show the benefits for the screening. The merge B scan does not help me to characterize the indications, or at least not directly. So I can also review that, and quickly I realize they are likely geometry echoes, and I have a lot of recurring patterns here. So I want to make sure that I'm not leaving one important echo aside. It seems that they are all pretty much the same, so I'm going to simply forget about them. Now I have a clear indication here, and I can see the facets actually. Looks like a crack. So I can even attempt to go at the deepest point, and sure enough, I can see some reflections there. So similarly, if I scroll through that bid indication, bid long indication, I can see it's a crack-like indication. And chances are that if I select what seems to be the deepest point, I may be even able to size it. So actually, I may want to do an exception just for this one. Okay, and I could use OmniPC, and I could attempt to size this, size the height very quickly using the actual cursors there. All right, so let me disable that where my cursor is. Okay. So I keep going, and then I have another indication simply because I can see some noise here. Okay, I can see the loss of geometry echo that's intriding. So I want to look at that, and I can tell there's something going on, but perhaps this index wasn't the best for displaying this indication. But at least I know that at 260, from 260 to 280, maybe 282, I'm gonna have possibly an indication to review with the other indexes. So I'm going to show you a couple more of these very similar welds, 3 to be exact. All right, so that's a new file. I have an ABCS layout, so this is already a good start, but now I have the gates in true depth. I will switch the gates to sound path, and I would like to display the has heat affected zone, so I'm just going to go in part. This is 1/2 inch. I'm going to type in an arbitrary value of 6 millimeter just so I can use it for my explanation. And that's probably an interesting gate selection for looking at the interesting portion of the weld. Now, if I activate my merge B, I can use my zoom and exclude what does not belong or what's less interesting. So now I can use that cursor to review each suspect indication. Clearly there's one here, but I can also see a few more that are worthy to look at. This looks like cap, but I have one here that looks like a very small, possibly indication right at the fusion line. So would I have been, maybe I would not have been able to isolate that from the C-scan. It's actually there when you know it, but it does not stand out that much. And then of course I have this big indication that looks like a fusion, and I can tell that the probe suddenly moved here because it drifted abruptly. It may just be the probe that got stuck momentarily and shifted position. So I also have some more indications in this area. They seem like geometry, but this is where the toggle comes handy. I can at any time use active beam, and I can still scroll the angles. See, now this particular beam 60 degrees shows more of the geometry and shows this possible lack of fusion there, small indication. And the more I scroll, the more I may feel more comfortable that I was actually seeing everything. So to perhaps reinforce the statement made earlier about can the merge B scan replace the screening totally, the scrolling of the B scan? I don't personally think so at this point. Well, this perception may change in the future, but I think it's still a good idea to screen at least at first. Make sure you don't forget anything, or at the last step like I'm doing now, but use the merge B to prevent additional scrolling of the B scan. And once you know you have not forgotten anything, you can use the merge B as a complement, as an additional view to reinforce or speed up your streaming phase. So I'm going to show you a couple more welds that are actually still quite simple ones. And then I'm going to make the problem a little bit more complex. All right, so this is a very similar weld. First of all, I have ABCS again, so I'm good. I'm going to change for sound path gates. I'm going to change probe and part, put a has, and set up my gates so they represent the interesting portion. All right, now this is the time to activate the merge B. And I have a few indications. I have one that is seen at 2 locations here. And I can tell why, because it's actually an OD. Looks like an OD connected indication that I actually can see the tip on the first leg. So it's showing at 2 different angles. So even though I zoom and exclude the first portion, I'm still catching the second one. So I can allow to do that. I can allow myself to do that. Now, how many indications are there? I see 3 obvious ones. I see something going on here that breaks from the geometry line that the C-scan, well, I wouldn't say so very clearly. That could possibly be porosity just looking at the signature. So I'm still looking for anything that stands out. Obviously, I'm back with that OD crack. And now I have another root location indication to review. Possibly a little bit of indication, so I need to make sure there's nothing. Okay. And a last step is scrolling all B scans. Did I forget anything? Nope, I did not. So I'm good. So that's how I can use the combination of merge B and not merge views in order to alternate between merge and non-merge. Depending on the weld, some weld that have so few geometry echoes may allow to void the streaming, the B-scan scrolling portion. Personally, I always feel safer to keep it just to make sure if I'm going to call an indication, I want to make sure I don't forget anything. So I'm using same methodology, ABCS. Again, this is me being a broken record, repeating the same things, but the method hasn't changed. I'm still using sound path because of my personal preference here, and activating the merge B scan. So in this case, I have one very clear indication, okay? But I also have something going on here on the C that the merge B does not necessarily show clearly. Okay, I can tell there's some amplitude going on here that's still catching my eye, but it's not as defined or alarming, let's say, as it looks like on the C scan. And there's a reason for it, because these indications, okay, seems that I still have a lot of geometry echoes, but I also have an indication that happens to be very much aligned on the on the axis perpendicular to their propagation axis. They seem very much aligned, or we could say they have the same sound path. So they do actually almost combine into one. So when that's the case, I can actually go in display. I can change the first beam and last beam, and I can try to isolate that for reporting purposes, for instance. Or if you have this as a recurring pattern in the weld, you may want to use that for your streaming also. But keep in mind the angles that you're hiding, because you're basically hiding a portion of useful angles more than likely. So you have to make sure you're not hiding defects by doing so, like I would if I would be using this too heavily. So that's a limitation of the merge B, is make sure that you're not leaving echoes that are hidden by one another, especially in the case of geometry echoes. One simple way to do it is either use the first beam controls, as we just demonstrated, or in any case, keep it with the active beam. Make sure you did not forget anything. So in this case, I would still have my suspect indication found, but I can still use the merge B for other function, other features in that weld. So moving on to another example. Now, this is not using a linear probe. This is using a dual probe with longitudinal waves, TRL, on stainless. This is the scan of a 30 or so millimeters thick pipe. By the way, it has a large cutout at the end, so I'm just going to ignore that portion between 700 and 800 millimeters. And as I'm straining straining using the B-scan roll technique, I see a lot of varying indications, but very few, actually not so many geometry echoes, only that. So this is potentially a very good candidate. If I activate the merge B, now I can see a lot of things going on in the same display. So all I have to do is review each suspect indication, like I could have here, but I quickly realized they're more or less relevant. And as I'm moving on, I'm particularly interested in the area at the top of my merge B and anything above the root here, root geometry, just in case it could be an ID track showing up. So of course there's some indication here. There's that big indication along the has, and another one that's kind of hard to judge from its location, but something more here. We see some height to it, very thin, very shallow, but still there's some indication. And I have a lot of indications in this area as well. And finally, an interesting one here. So DLA, typically dual linear probes or dual matrix probes using longitudinal waves on stainless, they are typically good candidates for the merge B scan. But like anything, there can be some exceptions to that. So I'm going to show you another example using another stainless steel weld with a similar dual linear array probe. The probe the signals I just shown you were with the A27 dual matrix. The new file that's loading were with the A26 dual linear array. So I have this ABCS layout, a lot of indications going on. And what I have here is actually backwall / cladding indications, and that's basically obscuring all of the C-scan. So as I'm scrolling in these indications, I can see the indications, but I have no easy way to plot them all in the same display. So I want to try the merge B, but the merge B has this actually a lot of echoes from the lower angles catching up the back wall and cladding. So I'm going to use the display feature and carefully isolate or reject these angles, because I'm trying here to make a screenshot for reporting that would include all of the indications of this qualification block. So in this example, I'm allowing myself to reject some of the angles just to provide a more clear screenshot using the merge B scan. So I can reveal this root indication here. Now, in case I could also have used gates in in true depth in this example. So I could start and I could start with gates like this, and I would have a C-stand that also shows me quite all of the indications in this case. Since I don't have any mode conversion or geometry echoes on the left side of my sector, I can actually produce a very decent screenshot using combination of C-stand and proper gate selection and the new merge B-stand. Couple more examples. I actually have 2 more examples before this webinar will be ended. This is a configuration where we have a pipe, probably a 12-inch, a little bit more than 12-inch pipe, 10 millimeters thick, single V weld. It's circumferential, it's carbon steel, 37.5 degrees bevel, using 2 A31 probes from Evident. Quite a nice configuration, except this pipe is giving us headache from the sheer quantity of geometry echoes that it has. So that weld is actually particularly rough on its surface. It hasn't been prepared, so we do have a lot of geometry echoes in cap and root are no exception. So I can tell there are some indications. There are some stronger indications in there, but I want to try using the merge B-stand and compare what this will look like once I have optimized each view. Now this is an 1100 millimeters, 1 meter scan, just enough for displaying all scan slices in one stream. So I don't have to necessarily zoom, but I'm going to go and repeat the same methodology. Single layout, ABCS using sound path, and these gates are already pretty well placed. So I want to, actually this was my merge B already activated. Now if I activate the merge B or deactivate it, I can stream. So here's one indication, another one, and possibly a third. Very shallow, so very small, I'm sorry. So, and here I have something else as well. So let's activate that and see what we can extract from this merge B-scan view. So there's a clear indication here. I want to zoom and see what I can, what I should display. I like to play when I have a lot of geometry echoes like this. I like to play with the first and last beam carefully again, just to make sure I'm not hiding any decent flaws. And this is a little bit too much. I'm going to leave it as high as I can and rather try to optimize from the lower angle. So I may want to pass the root a little bit. Let's go with 45 and see. Clear, correct light, a bit of porosity, and I want to deactivate it, make sure I did not forget anything. So this indication here may be detected from the other side at 950. So I'm going to check that on the other group. In here I have this indication that is also probably better seen on the other group. So I'm going to leave it active. Go to the main window, change group, go to the other side. This one had the merge B-scan already activated. Okay. So I'm sorry, this is the merge view. And now I can go to this display and try to refine this. But unfortunately, if I go too high in angle, I'm just going to lose this representation. So obviously do not want to do that. So I have these two views, these two groups probably optimized for the merge B. Now I can always go to the multiple view, change from ACS to the new ABS, and that is actually showing the merge B-scan views. So I can actually zoom that a little bit more for clarity. So now that allows me to see in a single display all possible indications that I have in this pipe. All right. I do have a last example for you. This is a demonstration piece that we actually very frequently use at our trade shows. So let's go on the single layout. I'm going to start with the 90-degree skew, and this is a compound scan. So I had the merge B scan activated. We can tell basically the compound scan is already displaying probably the best possible settings for the gate and the range. So we may want to look at the entire area of the merge B scan. So if I use the active beam, I doubt that I can miss anything, because there's only a geometry echo present at what, 64 degrees approximately, and it does not seem to be hiding much for as far as suspect indications. So I can probably safely use the merge B with this display. Now, if I wanted to, I could still try to limit the display angles, but in this case, I don't think I'll be winning much. So I'm just gonna use the entire set of angles. Moving on to the 270. Again, this has a little bit more weld geometry farther in the sound travel, but the first one, I'm always very much interested by the first one. So the first geometry line is very thin, and I feel I can see clearly all indications. So I'm happy with this representation. So I'm going to switch back to multiple layout and use the ABS in this case, and possibly even zoom a little bit further to use the merge B and review each of these indications. So I have one, something right after that. Okay, 2, 3, 4, 5, 6, 7, and as I'm counting, I'm looking at both of these B scans. I said 7, 8, 9, 10, and 11. Is there a 12th? Not really. Okay, so hopefully that was helpful. If there are questions in the chat, we're going to, let's see, are there any questions? None that I can see. So if there are any, that pop out, we'll answer after that, after the webinar. So again, thanks everyone for watching. Hopefully this was entertaining and helpful. So thanks again, and see you next time.